Hi. If you are watching, this is April 2025. This is lesson number 2. So I'm going to start with really modeling for you what a lead looks like. So a couple things I'm at home today. So orange juice from my fridge, Ziploc bag. I just went shopping at PetSmart, got my dog something. My son is addicted to Propel, but pretend it's a water bottle. Wait a second. And what do all these have in common? Um, they're made of plastic. What uh, what did plastic replace? And the answer is glass. In 1907, really, the technology was developed enough where plastic could be shaped and it was moldable, and it was a game changer. I mean, think about why plastic um, would be better than glass. It's not going to shatter. It's less expensive. It's easier to mold into shapes. And companies can have a higher profit margin based on that. Win-win. So here's the million-dollar question, is plastic recyclable? Even when it says it is, it isn't. So I'm going to share um, really just a very cool plastic pollution facts. 99% of plastic comes from fossil fuels such as gas, coal, and oil. We burn fossil fuels in the United States of America, really to create most of our sources of energy. 91% comes from fossil fuels, which is not good. This is what pollutes the environment. This is what's causing global warming. Because anytime you burn fossil fuels, gas, coal, or oil, you are emitting CO2. Carbon dioxide is CO2. We want to breathe in oxygen, not CO2. So it is depleting the earth of oxygen. Production of plastic is predicted to triple by 2060. So what's wrong with that? Well, this plastic bag is, right? See that? It is pretty lightweight. If that's dropped in a landfill, it will take roughly 100 years to decompose. This plastic in this or this will take 450 years to decompose if dumped in an ocean. Okay, I want you to for a moment think about how much plastic is in your refrigerator. Look at all the containers. And then I want you to think about school yesterday or whenever you had school and the cafeteria and everything that students put in the trash can. The trash can's probably lined with a giant black liner. All of that plastic. So what's the problem? We're destroying our planet. And production of plastic is predicted to triple by 2060. By 2050, greenhouse gas emissions from plastics could generate as much as 615 plants, which could use up 13% of the Earth's carbon. Carbon creates oxygen, right? So we need oxygen. Um, Plastic pieces break down into small toxic particles called micro and nanoplastics. So what's the problem with this? It's just flavored water, right? It's pretty thick, this flavored water versus just a water bottle. Plastic is made out of a chemical which has PCBs and DDTs. So the shelf life of water is about a year. And you're thinking, why is the shelf life a year? Shouldn't it last forever? No, plastic, the chemicals leach into the bottles, especially if they are heated. So this is why you don't want to heat plastic. Um, most plastic is dumped in landfills, illegal dumps in oceans, or escapes into the natural environment. Um, So there are microplastics and nanoplastics besides the chemicals that leach in, and anytime you drink it, you're drinking them. Microplastics, nanoplastics, scientists have found are interfering with the ocean's ability to absorb carbon. 70+% of our planet is covered in oceans. And anytime we dump into those oceans, we are threatening our own lives. Plastic threatens the health of wild animals, plants, humans, and oceanic life, and we all rely on each other to survive. Wild animals mistake plastic for food. Ocean marine animals either ingest it, become entangled in it. As a matter of fact, 100,000 marine mammals and turtles and 1 million seabirds are killed by marine plastic pollution every year. Plastic pollution is causing catastrophic harm. Today and every day, 8 million pieces of plastic pollution make their way into the ocean. 12 million tons of plastic is dumped into the ocean every year. Scientists now say 80% of all studied marine debris is plastic. There are approximately 51 trillion microscopic pieces of plastic weighing 269,000 tons. That's about the same as 1,345 adult blue whales and 500 times the number of stars in our galaxy. But the good news is plastic is strong, durable, and flexible. The bad news is these same qualities that make it such a great container mean it never really breaks down. The other thing, if you eat seafood, we know that marine animals are ingesting plastic. Well, if you're eating seafood, you're ingesting plastic too. The question is no longer, are we eating it? How much and how bad is it for us? Microplastics have now been shown to transfer from a pregnant mother through the placenta to her unborn baby. Microplastics, nanoplastics. Even if you don't eat fish or go to the beach, everybody breathes. Marine plants produce a massive 70% of essential oxygen. Okay, so the next page here, I have two smaller articles, and they really do put the information I'm about to give you in really easy to understand terms. Okay, so before I do that, I want to share with you. Okay, you're freaked out. I'm freaked out. It's not looking good. What are we doing? What are we doing to our planet? Well, the good news is science has come through with a solution. So here we go. Let me play the video. Very cool.
Japanese scientists at Riken Sands have developed a new supramolecular plastic.
I'm going to go run and put my orange juice back in the fridge.
Dissolves quickly in salt water, addressing the growing issue of ocean microplastics. Traditional plastics are durable, but persist in the environment for decades, harming wildlife and humans. Led by Takuzo Aida, researchers at Riken Center for Emergent Matter Science, or CEMS, created a plastic that breaks down into harmless compounds when exposed to seawater. The team focused on supramolecular plastics, polymers held together by reversible interactions. Their new material consists of two ionic monomers forming cross-linked salt bridges, ensuring both strength and flexibility. One monomer, sodium hexametaphosphate, is a common food additive, while the other is a guanidinium ion-based compound. Both can be metabolized by bacteria, ensuring biodegradability. Ada explained that while supramolecular plastics are often considered weak, their new material maintains durability. The key was making the salt bridges selectively irreversible. When mixed in water, the monomers formed two separate layers, one thick and rich in salt bridges, the other watery with expelled salts. The final plastic, alkyl sp2, was created by drying the thick layer. Desalting was crucial. Without it, the material became brittle. When placed in seawater, the plastic absorbed salt, causing its structure to destabilize within hours. This breakthrough offers a durable yet biodegradable alternative to conventional plastics, potentially reducing plastic pollution in oceans.
All right. What does all that mean, everybody? Okay. So I found two articles that kind of explain it pretty well. This is from the BBC, Great Britain. Whether it's food packaging from a shop or drinking juice from a plastic bottle, single-use plastics are a common part of life for many people. So it kind of introduces, just we all use plastic. But it's a big issue for nature and the environment. What's the problem? Each year, millions of tons of plastic end up in the sea, most of which isn't biodegradable. That means it doesn't break down over time like paper or fruit. So instead, it can hang around in the environment for hundreds of years. And when larger pieces of plastic, such as drink bottles, do break down, they can turn into much smaller pieces called microplastics, which can be swallowed by wildlife. Okay, so what that is an example of, ladies and gentlemen, is a lead. A lead is how they start articles. They hook you, they grab your attention. They give you information that, whoa, that's alarming, give you the problem, give you, you know, how it connects to you, which is pretty much how I started class. I'm going to scroll down and give you this one in purple as well. This is I actually like this article better. This is from Dogo News. It's a kids magazine. Sorry, I'm having trouble talking today. Plastic pollution is one of the world's most pressing environmental challenges. A large portion of the 400 million tons of plastic produced annually ends up in landfills or the ocean. Unlike organic waste, plastic never decomposes. Instead, it breaks down into tiny pieces called microplastics. These particles contaminate water, soil, and air, harming marine life, livestock, and even humans. Another great example of a lead. So why am I telling you this? Every single student is asked to try a lead. I gave you an entire page of plastic pollution facts. My suggestion, what are the most relevant ones for most people? What are the most attention-seeking, attention-grabbing comments? And then connect that together, much like both of these did. So I'm going to go back up here and I'm going to finish this one. Scientists and manufacturers have been looking for environmentally friendly alternatives to conventional plastic, and researchers in Japan say they've now developed a version of the material that will fully dissolve in the ocean. Tests showed that the new plastic would start to break down within hours when placed in salt water. And when put into soil, the sheets of the new plastic degraded in 10 days and supplied chemicals similar to fertilizer, which helps keep soil healthy. What? A water bottle would break down within hours in the salt water? And this bag would break down within 10 days and create fertilizer? Wow. That's a game changer, y'all. Takuzo Aida, who led the study, said, quote, with this new material, we've created a new family of plastics that are strong, stable, recyclable, and can serve multiple functions, and importantly, do not generate microplastics. How was the recyclable plastic discovered? While some recyclable plastics do exist, the main problem is what happens when they enter the sea. They don't break down in water. In fact, some plastic waste can take more than 500 years to break down at all. So to solve this problem, scientists at the Riken Research Institute in Japan worked to develop a plastic that would remain strong, but would be able to fully break down in environments such as soil and seawater without leaving any microplastics behind. So if this is true, everyone, this is a game changer. Game changer. We can't undo the damage we've currently done. We've done a lot of damage. Whatever is existing plastic that's harming our planet will remain. But if we can, I don't know, with government intervention, government mandates, or, you know, they can reproduce this, make it less expensive than the current plastic, we can stop the damage, stop it in its tracks. The next article, I've already read the lead. A team of Japanese scientists hopes to solve the problem with a new plastic that fully degrades in soil or seawater. Researchers at Japan's Riken Institute set out to create this material with two main goals. They wanted it to be strong and versatile, while also breaking down in soil and seawater without leaving any microplastics behind. To achieve this, the scientists developed a special polymer with weaker molecular bonds than traditional plastic. These bonds break more easily, allowing the material to fully biodegrade in natural settings. Love this next part. Microplastics in the ocean are ingested by fish and shellfish and then consumed by humans. So I love this analogy here. Think of the plastic we use today as the difference between a rock and a sugar cube and the new plastic. Regular plastic behaves like a rock. It may break into smaller pieces. It never truly disappears. This is a great thing to put in your essay if you want to. The new material, however, dissolves like a sugar cube in water, leaving nothing harmful behind. In tests, the new plastic began breaking down within hours in seawater. It also fully decomposed in soil within 10 days. As it broke down, it even released nutrients that could help plants grow. The findings were published in the journal Science on November 21st, 2024. The team now faces the challenge of increasing production and making the plastic affordable for everyday use. If they succeed, it could replace traditional plastic in everything from 3D printing to medical devices and consumer goods. Okay, so I'm going to try to save my voice here a little bit, and I do this in class as well. The next article, you're going to listen to this one this time. Having a little trouble with my voice today. Just residual stuff, doing okay. Just trying to save my voice so I can get through classes tomorrow. So the next article, it's a little challenging, everybody. This is the original article that was documenting the discovery. Very scientific. So I'm going to have you listen to this one. Here we go. Bye-bye microplastics. Okay. Bye-bye microplastics. New plastic is recyclable and fully ocean degradable. This article is from November 21st, 2024. This is the original article. Researchers led by Takuzo Aida at the Riken Center for Emergent Matter Science have developed a new durable plastic that won't pollute our oceans. The new material is as strong as conventional plastics and biodegradable, but what makes it special is it breaks down in seawater. The new plastic is therefore expected to help reduce harmful microplastic pollution that accumulates in oceans and soil and eventually enters the food chain. The experimental findings were published November 22nd, 2024 in Science magazine. Scientists have been trying to develop safe and sustainable materials that can replace traditional plastics, which are non-sustainable and harm the environment. While some recyclable and biodegradable plastics exist, one big problem remains. Current biodegradable plastics like PLA often find their way into the ocean where they cannot be degraded because they're water insoluble. As a result, microplastics, plastics bits smaller than 5 millimeters, are harming aquatic life, finding their way into the food chain, including our own bodies. In their new study, Aida and his team focused on solving this problem with supramolecular plastics, polymers with structures held together by reversible interactions. The new plastics were made by combining two ionic monomers that form cross-linked salt bridges, which provide strength and flexibility. In the initial test, one of the monomers was a common food additive called sodium hexametaphosphate, and the other was any of several guanidinium ion-based monomers. Both monomers can be metabolized by bacteria, ensuring biodegradability once the plastic is dissolved into its components. While the reversible nature of the bonds in supramolecular plastics have been thought to make them weak and unstable, says Aida, our new materials are just the opposite. In the new material, the salt bridge's structure is irreversible unless exposed to electrolytes like those found in seawater. The key discovery was how to create these selectively irreversible crosslinks. I'm not contagious anymore. You don't have to cover your mouth. It was when I was. As with oil with water, after mixing the two monomers together in water, the researchers observed two separated liquids. One was thick and viscous and contained the important structural cross-linked salt bridges, while the other was watery and contained salt ions. For example, when sodium hexametaphosphate and alkyl diguanidinium sulfate were used, sodium sulfate salt was expelled into the watery layer. The final plastic, alkyl sp2, was made by drying what remained in the thick viscous liquid layer. The desalting turned out to be the critical step. Without it, the resulting dried material was a brittle crystal unfit for use. Resalting the plastic by placing it in salt water caused the interactions to reverse and the plastic structure destabilized in a matter of hours, thus having created a strong and durable plastic that can still be dissolved under certain conditions. The researchers next tested the plastic's quality. The new plastics are non-toxic and non-flammable, meaning no CO2 emissions. They can be reshaped at temperatures above 126 degrees Celsius like other thermoplastics. By testing different types of guanidinium sulfates, the team was able to generate plastics that had varying hardness and tensile strengths, all comparable or better than conventional plastics. This means the new type of plastic can be customized for need. Hard scratch resistant plastics, rubber silicone like plastics, strong weight bearing plastics, or long tensile flexible plastics are all possible. The researchers are also created ocean degradable plastics using polysaccharides that form cross-linked salt bridges with guanidinium monomers. Plastics like this can be used in 3D printing as well as medical or health-related applications. Lastly, the researchers investigated the new plastic's recyclability and biodegradability. After dissolving the initial new plastic in salt water, they were able to recover 91% of the hexametaphosphate, 82% of the guanidinium as powders, indicating recycling is easy and efficient. In soil, sheets of the new plastic degraded completely over the course of 10 days, also supplying the soil with phosphorus and nitrogen similar to a fertilizer. With this new material, we've created a new family of plastics that are strong, stable, recyclable, can serve multiple functions, and importantly, do not generate microplastics, says Aida. Okay, now you know why I didn't want to read all that. A lot of the terms, it's hard to get your mouth around that. Okay, so I'm going to give you two really big tips. Like, you can't go wrong with these tips. The first tip, you want to identify, there's my voice, the 5 W's in the article. Who, in all 3 articles, was this about? Researchers in Japan, led by Takuzo Aida. What happened? They developed a new durable plastic which breaks down in seawater and oil. Where? At the Riken Center for Emergent Matter Science. When? That's November 21st. That date is wrong. 2024. Why? To replace current non-biodegradable plastics which pollute landfills, oceans, and the atmosphere. Now, the how is just good to know. The new plastic was developed when scientists developed a specific polymer. I would say discovered, so I didn't use that same word twice. A specific polymer by combining 2 ionic monomers, which break down easily in water and soil. Okay, so how does that work then? All you have to do is combine the 5 W's. Here's an example. Recently, Japanese researchers led by Takuzo Aida at the Riken Center for Emergent Matter Science, and I don't even think you'd have to put that, designed a new durable plastic which dissolves in seawater because of special polymers which resulted when 2 ionic monomers were combined. I don't even like that. Is it? Okay, okay. In seawater, I would say, and soil. Okay, where researchers led by China developed a new durable, okay, at the Riken Center, which will replace current non-biodegradable. Hello. I didn't like my sentence. Plastics, which now pollute landfills and oceans. I can go in and edit myself, everybody. Okay, so here we go. Here's your assignment, everybody. I want you to explain using interesting facts why current forms of plastic are such a significant problem in the world today. Now, you have 2 examples given in the 2 first articles, and you have my whole page of plastic pollution facts. So let me just tell you a secret. Journalism 101. They start with the 5 W's, always, because a lot of times if your story is cut, you better get that part out. In writing, we start with a hook. We start with a lead, really, which is the reason for listening to this essay. Then I want you to combine the 5 W's, and I'm going to change mine back to this one because I liked this one that I just wrote better. I'm going to put that one here. I'm going to make that smaller so you're actually seeing me in action, changing my essay. Okay, so then we're going to do body paragraph number 1. This is really, the 5 W's here, by the way, you can combine those in any way you want. So all you have to do is change the order. You're not plagiarizing. I've already given you the $5 bills. Change the order and you're good. So everyone should be able to do right here, this introduction paragraph. So in an introduction paragraph, we start with a lead and we end with the thesis. So this right here should be 4 to 5 sentences. I would say minimal. Maybe even 5 to 7 sentences, because you should have eight sentence paragraph. Okay, so body paragraph number 1, here comes the tricky part. Those of you that came to class, well, obviously, if you're watching this, you come to class. The number one issue that kids have, especially with scientific articles, the internet, is they plagiarize. And I don't think it's intentional. I don't think it's like, I'm gonna cheat today, right? I think it's, I don't know how to say this better. So I'm going to give you my second trick of today. Besides the 5 W's, I'm going to give you my second trick of the day. If it sounds so good that you can't make it any better, quote it, but only partially quote it. Only quote the parts that you can't say better. The rest of it, summarize yourself. So you'll notice down here, I've given you 3 sections of information, and I quoted that from the article. Okay, if you look at that and you quote that much of the article, that's cheating. And that's technically not plagiarizing because I did quote, but you're cheating because the majority of the essay is the quotes. So you can't do that. So let me show you by this one right here. First, the team made the new plastic by combining 2 ionic monomers that form cross-linked salt bridges, which provide strength and flexibility. One of the monomers was a food additive called sodium hexametaphosphate, while the other was any kind of, quote, guanidinium ion-based monomer. Notice I quoted like salt and pepper. It's not all quote. I used only the words that were, woo, I couldn't say it any better. That's what I want you to do here. I want you to summarize that information in like 2 sentences, maybe 3. Secondly, the researchers mixed the 2 monomers in water, noticing how they reacted as 2 separate liquids. I put that in my own words. One of the liquids was thick, containing, quote, the important structural cross-linked salt bridges, while the other liquid being watery and contained salt ions. Again, just smaller quotes. Again, summarize this information below in 2 to 3 sentences. Finally, the researchers tested the quality of the new plastic to make sure they remained non-toxic and reshapeable above temperatures with temperatures above 120 degrees Celsius, which is what happens with other thermoplastics. Summarize the information in blue. This new plastic, if it can be duplicated, can reduce plastic pollution on land and in oceans, which would limit its harmful effects on the earth and in humans. Okay, so obviously, great. So this scientific breakthrough by Aida and his Japanese research team, where they have been able to develop a new kind of formula for plastic, which allows it to dissolve in seawater and on land. And on land, could save the planet. Okay, I'm going to tell you a conclusion. I don't want anyone to write one. If there was a way to rid the landfills and oceans of plastic pollutants, it would be a game changer for waste disposal and reducing carbon emissions impacting global climate change. Here's an example of, how you could do that. So here is my version. Notice it's in MLA format, Mary Hensel, April 16th. I love the title. Please do not put plastic in the title. So I've given you my own example of a lead, and then my own example here. I want to share with you. I actually had a student today. I'm going to see if I can pull up her essay. I thought she did a really good job on her body paragraph. So I'm going to that wrong. She did a great job of putting it in her own words. So I'm going to actually student example of body paragraph without any plagiarism. It was good. Can be done. So yeah. And then I gave you my example here. And I've even kind of showed you the edits there. Okay. Wow. That was a lot, wasn't it? Let me stop share here. Okay. Woo! This is cool. I'm actually pretty excited about this. I think the world needs to pay attention. I think it's going to take time for plastic production companies to get on board. But if they do, your children, your children's children, your children's children's children will still have a world to live in. All right. This concludes lesson number 2. Thank you for watching. I know it is a holiday weekend, so I wanted to make sure I posted this.